So this is quadratic attributes, the day 2 notes. It's just a continuation of what we did yesterday. So it says, is the above function in standard form? Well, you need to remember standard form is ax squared plus bx plus c. If we look at the equation, it is still in standard form. If it wasn't, you would just need to move over whatever wasn't on the right side. So we'll write it just so we have it for our notes. So x squared plus 3x plus 4. And then it asks us to identify our a, our b, and our c. So remember the a is the number in front of the x squared. Well, this time we don't have a number. So that means it's just going to be 1. B is the number that's in front of the x. So in this case, it's a positive 3. And then the last one is the c. And the c is important because we need to remember the c is our y-intercept. So looking, the c is 4. So that means that my y-intercept is 0, 4. If you look at your graph, you can check your answer. It crosses the y-axis. This is my y-axis. I'm still highlighting in the same color because they go together. That's your y-axis. Wherever your parabola crosses it at, that's your y-intercept. The next question is the x-intercept. Does my graph cross the x-axis anywhere? In this case, no, it does not touch the x-axis at all. So that means that it has, we'll just write the word none. It has no x-intercepts. Remember, x-intercepts go with my number of solutions. Your number of solutions can be 0, 1, or 2. In this case, because there are no x-intercepts, my number of solutions is 0. All right, so other words they could use instead of solutions could be zeros or roots. We need to remember they could ask the same question 4 different ways. What are your zeros? What are your roots? What are your solutions? These are all names for x-intercept. Looking at my graph, does it open up or does it open down? In this case, looking at my parabola, it's gonna open up. This, also another important thing, can go back to your a value. All right, this is also important, your a value. If it's positive, then it's gonna open up. If your a value is negative, then it's gonna open down. Be sure you write this down because it's important. If it's a positive a, it opens up. If it's a negative a, it opens down. It's opening up, so it's a positive a value. Then my vertex. So for vertex, let's go ahead. We'll put it in our calculator. So let's go ahead and we'll graph the vertex. So by doing that, we'll go to new document. Do you want to save? Say no. Go to add graphs. So then type it in just like it's written. We have x squared plus 3x plus 4 and hit enter. So it pops up there. You get the whole picture so we don't have to zoom in or zoom out, and do menu, analyze. And in this case, looking at our picture, did we have a minimum or do we have a maximum? Well, looking at our picture, we have a low point. Our U opens up, so we have a low point, so that means we have a minimum. Our minimum. So when we go in to find our vertex, we select minimum. You want to take your dotted line and you want to be to the left of the parabola. Click. Highlight your vertex. Make sure you're to the right of it. Click again. So if you look, our vertex is going to be at negative 1.5, 1.6. 1.75. So I want to take a little extension off of this, and I want to talk about axis of symmetry. We talked about the vocabulary word a little bit yesterday, but now let's see where it comes from. So what our axis of symmetry is it cuts, it's an imaginary line that cuts our parabola in half. All right, so what we need to remember, it's a vertical line, so it has undefined slope, and it is x equals a number. Remember, hoi vux, all right? It's a vertical line. If you want to write that down here by your VUX, so it's x equals a number on your notes. So my axis of symmetry is an equation, so it's going to be x equals, and in this case, it's going to be x equals, what color do I want to use? Go with green. X equals the x value of your vertex. All right, so in this case, it's x equals negative 1.5. I know that's kind of hard to read. If you want to rewrite it, x equals negative 1.5. That's where it comes from. Okay, it comes from the vertex. Your vertex is responsible for a lot of information. So then as we continue on, we go to our min-max value. And remember from yesterday, that's the y value of the vertex. So we get it from right here. And remember, we're also going to use that number for our range. So your minimum value is going to be 1.75. And then your range, you're going to have y and then leave a space, 1.75. Now, for range, are we using all the numbers above it or below it? Above means greater than or equal to. Below means less than or equal to. So we're going above. So it's going to be greater than or equal to 1.75. And then your domain is still all real numbers. Always your domain, your x values are always all real numbers. Looking at your second problem on quadratic attributes for day 2. It says, is the above function in standard form? What we need to remember, standard form is ax squared plus bx plus c. So in this case, looking, this one is in standard form. Let's rewrite it though, just for our notes, so we have somewhere to write. So we need to remember, a is the number in front of the x squared. B is the number that's in front of just the x. And then C is the number that's by itself. What we need to remember is that C is also important because it tells us our y-intercept. So when looking, my A then is a negative 1. B is 3. C is 4. Making my y-intercept 0, 4. You can check it by looking at your graph. Where does the parabola cross the y-axis at? Well, on this one, if you want to count it, it's 0, 4. Your x-intercepts are where does your parabola cross your x-axis at. Remember, this determines your number of solutions. When looking at my graph, it crosses at, it looks like negative 1, 0, and then 4, 0. It had 2 solutions. That's why we had 2 x-intercepts, so we have 2 solutions. Remember, your options are that you can have 0, 1, 2. You can have 0, 1, or 2 solutions. No more than that for parabolas. If we're looking at, does our circle open up or does it open down? This goes back to our A value, okay? If your A value, if you have a positive A value, then it's going to open up, all right? If you have a negative A value, guess I could draw the picture, then it's going to open down. Okay, so in this case, we had a negative A value, meaning it's going to be opening down. If you don't believe me, you can look back at your picture. Your parabola shows that it is opening down. Looking at my picture, it has a high point, which means that it's going to have a maximum value. I know I changed that opening up or down to match the A value. So if we want to go back, or we have to graph it to find our vertex, you're going to do new document. Do you want to save? Say no. Go to add graphs. Type it in just like it's written, negative x squared plus 3x plus 4, and hit enter. There's your graph. So menu, analyze. It has a maximum. You still want to be to the left of your high point. Click and then scroll over to the right of your high point. Our vertex is going to be 1.5, 6.25. So my vertex is 1.5, 6.25. The point I want to add in is our axis of symmetry. Your axis of symmetry is a vertical line. We kind of touched on the vocabulary word yesterday. That cuts your parabola in half. All right? Because it is a vertical line, it has undefined slope, and your equation is x equals a number. So in this case, when you go to write your axis of symmetry, is the, sorry, I want to make sure we use a different color, x value of your vertex. So in this case, my axis of symmetry is going to be x equals 1.5. Your axis of symmetry is x equals 1.5. Your min or max value, you need to remember, comes from the y value of your vertex. So in this case, the y value is 6.25. It also determines your range. So you're going to have a y, leave a space, and then 6.25. In this case, looking at my graph, are my y's above 6.25 or are they below 6.25? They're going to be below, so it's less than or equal to 6.25. Your domain is still always all real numbers.